The first question we're going to tackle is to determine the mass of a single H2O molecule, aka the formula mass of water. What it's really asking, a single water molecule has X number of grams. We'll put that at the top of the screen to finish the problem. What do we have and what do we need? We need to find the mass of a single water molecule, and we have the molecular formula of water, H2O. Likewise, we know the mass of the elements that compose water, hydrogen and oxygen. We can look at the periodic table and see a single atom of hydrogen is 1.008 atomic mass units, and we have two of them. And the mass of a single oxygen atom is 16 AMU. So here we have the atomic masses of hydrogen and oxygen, and we know that per molecule of water, we have two H atoms and one O atom. So in order to account for this, we need to scale the atomic masses of these elements accordingly. In other words, the total mass of a single molecule, in this case water, is the function of both the atomic masses of the elements which compose that molecule, as well as the relative abundance of the elements in that molecule. Put it all together, and the mass of a single water molecule is the addition of atomic masses of O and H, each scaled to their relative abundance within H2O. Expand everything out, cross out the units, and we are left with the mass contribution of hydrogen plus the mass contribution of oxygen. And we get that a single water molecule is 18.015 AMUs. Next question is, what is the molar mass of water? And we're going to find this in terms of grams, since that's the SI unit for mass. Another way of writing this is that there are a certain number of grams within 6.02 times 10 to the 23 molecules of H2O. What do we have and what do we need? Well, we need to find the molar mass of H2O, and we know what the molecular formula is. We also know the masses of the individual atoms which compose water. There are 1.008 grams in a mole of H atoms, and we have 2 moles of them. We also have 1 mole of oxygen atoms, which has the mass of 16 grams. We have our molar masses of each atom that compose water right here, so we're one step closer to solving the problem. Now let's see what else we can do. We also take into account the relative abundance of H and O per molecule of water. Put it all together, and the molar mass of water is the addition of molar mass of H and O, each scaled to their relative abundance within H2O. Expand everything out, cross out the units, and we get the mass contribution of each atom, O and H. Molar mass of water is 18.015 grams. As you can see, terms and calculations are directly analogous for the formula mass and molar mass of the same compound, in this case water. Once you have a solid foundational understanding of these two problems, here's a quick connection between them. Molar mass is the product of the mass of a single unit of something and Avogadro's number. This is the mass of a single AMU in grams, and it connects between molar mass and formula mass. By extension, we see that a mole of protons has exactly a mass of 1 gram.